What's up, everyone? Sergeant Arger right here. And well, that's great. Anyways, Sergeant Arger right here, and today we're gonna be reacting to, or finishing our reaction to, Time-Lapse of the Future. And sorry I've not been, making videos in the past few days, because I've been sick. I still am kind of sick, but I don't know if you can hear it in my voice. But anyways, yeah. So that's the reason why I haven't been feeling too good. And also, I decided to make, the amazing, I had the amazing idea of taking NyQuil, earlier than I should have. And then I was like, oh wait, I still need to make a YouTube video, because I haven't been making videos in a few days. So, yeah. It took maybe 30 minutes ago. So hopefully hopefully I can make it through the video. But anyways. Because whenever I take NyQuil, I don't know. It's weird. But anyways, let's continue with where we were.
Zombie galaxies filled with black holes.
Oh. Zombie galaxies.
They'll eat each other and they'll get bigger, and maybe they'll fall into the same type of
each other.
And it'll get bigger. The universe will still be an exciting, dynamic place. It's just that the timescales are talking.
I want to see a black hole eat another black hole. That would be cool.
Talking about are now trillions of years instead of thousands or millions.
Look how fast! Look how fast it's going! 160 trillion. Look how fast it's going. What the heck? How is it even possible? What am I watching right now? What is that weird white stuff? I call it some of the most fascinating things ever. Trillions of trillion. Excuse me, what? You just say trillions.
Black holes can bang on space-time like mallets on a drum.
Oh, cool.
And they have a very characteristic song.
A song? What? I don't think they
Imagine two
sing.
black holes that have lived a long life together. At the end of their lives, they're going around each other, crossing thousands of kilometers in a fraction of a second. As they do so, they leave behind in their wake a ringing of space, an actual wave on space-time.
What in the world?
Space squeezes and stretches as it emanates out from these black holes banging on the universe. Those are the gravitational waves. They're literally the sounds of space ringing.
What are those weird oval things?
At the speed of light as they ring down and coalesce to one spinning, quiet black hole.
What in the world?
If you were standing near enough, your ear would resonate with the squeezing and stretching of space. You would literally hear the sound.
So I guess you can hear some sounds in space. Huh. It's cool. That's fast.
Imagine a lighter black hole falling into a very heavy black hole. The sound you're hearing is a light black hole banging on space each time it gets close.
What? Excuse me, what?
As it falls in, it gets faster and it gets louder.
used to think black holes were immortal, but even these will one day die.
Now we're talking about timescales of unimaginable length, quadrillions of years into the future. On that timescale, even the black holes begin to evaporate.
According to quantum mechanics, space is filled with virtual particles, antiparticles, that are constantly materializing in pairs, separating, coming together again, and annihilating each other.
Rest in peace, Stephen Hawking. He's a very intelligent
In the
man.
presence of a black hole, one member of a pair of virtual particles may fall into the hole, leaving the other member without a partner with which to annihilate. The forsaken particle appears to be radiation emitted by the
Oh, and that's Hawking radiation.
black hole.
Oh, and it literally says it at the bottom. I've heard about this before.
And
So I guess there is a one thing that can escape black hole's gravity.
black holes are not eternal. They evaporate away at an increasing rate until they vanish in a gigantic explosion.
Oh my god, what kind of explosion would that be?
Quantum mechanics has allowed particles and radiation to escape from the ultimate prison, a black hole.
So basically, at the end of time, there'll be nothing except for this Hawking radiation. I guess. And we still have 10 more minutes. What? This is not the end. I keep saying that, but like, what else would there possibly be? Look at that. It's cool. What in the world are those things? I really like how the universe continues to expand. I'm not serious words we don't yet understand. It's the frontier of human knowledge, frontier ripe for exploration and discovery.
Philosopher.
What is that like expanding into though? Like, what is what's outside the universe? What is it expanding into?
And poets have asked the question, will the world end in fire or ice? We can now give an answer. The latest evidence shows that the universe is not slowing down, but it's speeding up out of control. And the universe, we think, will die in ice. Trillions upon trillions of years from now.
Empty space itself has energy. In every little cubic centimeter of space, whether or not there's stuff, whether or not there's particles, matter, radiation, or whatever, there is still energy even in the space itself. And this energy, according to Einstein, exerts a push on the universe.
Oh yeah, dark energy.
What is the weird stuff that's accelerating the universe? We call it dark energy.
Is it right there?
And the stuff is the dominant stuff of the universe.
You know, like, I saw this like chart one time, I think. And it says apparently like the majority of the universe is controlled by dark matter and dark energy, and they come up with this stuff because we can't really like see it with our eyes or anything like that. So, and like looking at solar systems and galaxies and stuff, and we're and like I don't know, clusters of other kinds of stuff, and we're Oh my gosh. I am so congested right now. And like this, the sun and the other objects, there's not enough gravity to keep them all together, so there has to be something else. And we're calling that like dark matter and dark energy. That's like a really brief summary, I guess. What in the world? Oops. What the heck? Anyways, let's keep watching.
Almost 3/4 of the matter-energy content of the universe is this dark energy, and we don't know what it is.
Dark
Crazy,
energy,
man.
unlike matter or radiation, does not dilute away as the universe expands. This has crucial implications for what the universe is going to do in the future.
So what will be the future of the universe? Well, if the dark energy remains dominant and repulsive, the universe will expand forever.
What am I looking at?
Faster and faster and faster with time. A runaway universe.
70% of the energy of the universe resides in empty space, and we don't understand why. But we do know what will happen. If that energy continues to be there, the universe will become cold and dark and empty. That's the future as it might be. We don't know because we don't yet understand the nature of dark energy. Until we do, we won't know the future. We won't even understand our own origins, and that's why we want to know and study this subject.
Well, maybe humans in the far, far future can sustain themselves with dark matter and dark energy or whatever. You know, once we actually understand it. How could it tear the universe? What? That work?
Does seem to be for an ever colder, ever emptier universe. But then, of course, we have to ask, could that end lead to a new beginning?
I don't know.
And there are ideas whereby what actually is the end of our universe could in some sense be linked to the beginning of a new one.
Speculate that there may be Oh. That would be weird, creating our universe.
We've worked out the mathematics, the equations. They seem to say that if you have an atom smasher that can concentrate tremendous amounts of energy at a single point, you can perhaps open up a gateway, a baby universe. Facing the death of everything there is, this perhaps is their only possibility of escape.
Wait, so that would just create a universe inside of our universe. But does that mean that maybe there's like other universes inside of our universe? Or maybe we're inside another universe? I don't know.
And this also also raises a very intriguing possibility, sheer speculation, of course, that perhaps any universe that has intelligent life in it will create baby universes, will create lifeboats, and proliferate child universes. So an evolution may take among universes in the multiverse. Survival of the fittest may take place. So those universes which do not have intelligent life are infertile. They have no children. But those universes that have mild temperatures, stars like us, would create civilizations that could open up child universes, and they would then proliferate.
There's no way to escape the universe, then I'm sure the last one zero massive black holes. Oh no, that's not good. The last one explodes and dies and bathes the universe in light one last time.
An unimaginable length of time. Even
oh my, look how many trillions there are at the bottom.
The black holes will have evaporated, and the universe will be nothing but a sea of photons gradually tending towards the same temperature as the expansion of the universe cools them towards absolute zero.
Wait, they say that, like, entropy will constantly increase until the end of time. What happens after all the black holes are gone? Then there is no entropy. It's only, I guess, what the opposite of infantry. Yeah. Infantry. Whatever it's called is. So then it just, you know, order. Like forever, except for these tiny particles, I guess.
Once the very
entropy,
yeah. Of the very last stars have finally decayed away to nothing, and everything reaches the same temperature, the story of the universe finally comes to an end.
Oh, yeah.
For the first time in its life, the universe will be permanent and unchanging.
Wait, that just made me realize something. Time only exists because of entropy. If there isn't entropy, then there's no time, because nothing is changing, and time only exists because things are, you know, changing. If you think about it, like everything stayed still, though no way to be telling time. You know what I mean?
Stops increasing because the cosmos cannot get any more disordered.
Seriously, that is interesting though. Time is dependent on entropy. They're connected. That's crazy.
It happens, and it keeps not happening.
And that's why entropy has to increase, I guess, until here. Then there'd be no more time.
Forever.
Young class in science, and I learned whatever state I may be in, there ain't no constant. Helen Keller. Anyways, wow. That was an amazing, that was a masterpiece, to be honest. Much better than the other video I reacted to, where it was, talking about the time lapse of the universe, like in the past. So yeah, thank you all for watching, everyone. Subscribe to Melodysheep, and goodbye. Hello everyone, if you enjoyed this video, make sure to like it and subscribe to my channel. And you know, turn on the notification bell thingy. And if you didn't, then make sure to leave a thumbs down. Oh yeah, that would be greatly appreciated. And while you're at it, go ahead and watch my other videos. They're probably just as good, and if not better than this one right now. Except for my oldest videos, don't watch those. And, you know, subscribe to these people down here, my fellow sergeants. They're other YouTubers that I either know or I have in high regards. Yeah, even my cat agrees. So, thank you for watching, and have a great day.